These are the solutions to the teacher-created problems from test number 1. A horticulture designer wants to enclose a rectangular flower bed of maximum area using no more than 500 feet of fencing. That is, she wants to maximize A equals LW, where L is the length of the flower bed and W is the width. Write an equation using L and W that shows that she will use 100 feet of fencing. In this rectangular flower bed, she has L feet of fencing here and here. That's L plus L. She has W feet of fencing here and here. That's 2W. 2L plus 2W equals 500 feet of fencing altogether. And that's the answer. This is different from the question that was on the practice test because the rectangle on the practice test had only 3 sides of fence. 1, 2, 3, because one side of the fence, one side of the pen on the practice test was along the barn. This black here, there was no fence here. So on the practice test, it was L, just 1L plus 2W equals however much fence was in that problem. So this question is done because we did this. We wrote an equation using L and W that shows that she will use 500 feet of fencing. This is the same problem, but we, in this problem, are to write the equation, that's this equation, with only the variables A and W. So without L, we're going to replace L with an expression that L is equal to, using the equation that you entered in the last question. In the last question, we had 2L plus 2W equals 500. We're going to find what L is equal to by subtracting 2W from both sides. And then we're going to divide by 2. 2L divided by 2 is L. 500 divided by 2 is 250. Minus 2W divided by 2 is minus 1W. The objective function, A equals LW, can be written as A equals, replace L with what L equals, 250 minus W. So that's L times W. And there's the answer to this question. It could also be written like this: A equals W times 250, which is 250W, minus W times W, which is W squared. That's all we had to do for this question. So read the directions and you'll see that's what is expected. Using your objective equation with only A and W from the last equation, so that was A equals 250W minus W squared. Let's double check. That's it. So using that, we want A prime. A prime, the derivative of 250W is 250, and the derivative of minus W squared is minus 2W. And this is what you would put into that box. On Delta Math, as you type something, the box gets bigger to fit whatever you're typing. A double prime, the derivative of this, of A prime, is 0 minus 2. A double prime is negative 2. And the first derivative, let me start this over. We're going to do some stuff that isn't asked for here in order to fill in the rest of the blanks. We're going to find when the derivative is equal to 0. The derivative is 250 minus 2W equals 0. Subtract 250 from both sides. and divide both sides by -2. Negative 250 divided by -2 is positive 125. When the first derivative evaluated at 125 is 0, and the second derivative evaluated at 125 is a negative number, because the second derivative is always -2. By the second derivative test, using these two pieces of information, the area is maximum when the width is 125 feet. The length we find by going back to here, L equals 250 minus W. From the previous question, L equals 250 minus W. So L equals 250 minus W is 125. And 250 minus 125 is 125. That goes here. Let's make this a little neater. And we're done with this. Given f of x equals 2x cubed minus 12x squared plus 30, the derivative f prime of x equals 6x to the second minus 24x to the first plus 0. And now we're going to find when the derivative 6x squared minus 24x is equal to 0. We're going to factor out 6x. 6x times x minus 4 is equal to what's right above it, equals 0. This is true when 6x equals 0 or when x minus 4 equals 0. 6x equals 0 when x equals 0. And x minus 4 equals 0 when x equals 4. When x equals 4, when x equals 0, plug 0 in here. F of 0 comes out to be 30. And when you plug 4 into here, into this original, f of 4, 2 times 4 cubed minus 12 times 4 squared plus 30, that comes out to be negative 34. F of x means y. Here's f, f prime, and x. The two critical numbers are x equals 0 and x equals 4. When x, this is the x-axis, when x is 0, f prime is 0. And when x is 4, f prime is 0. A number smaller than 0, like -1, plug -1 into this. This is f prime. You'll see a negative times a negative, which is a positive. Plug a number between 0 and 4, like 1, for instance, in here. Plug 1 in, you'll have a positive times a negative, which is a negative. And if you plug any number bigger than 4 in here, like 5, 6 times 5 times 5 minus 4, that's a positive times a positive, which is positive. This tells us that f is increasing, then decreasing, then increasing. So f has a maximum when x is 0, maximum at the point 0, 30. The minimum is here, down then up, so minimum when x is 4. That's at the point 4, negative 34. For inflection point, we need the second derivative. The second derivative is from this. The derivative of the first derivative is 12x minus 24. The second derivative, 12x minus 24, is equal to 0 when we add 24 to both sides and divide both sides by 12. F double prime x. When x is 2, the second derivative is 0. Any number smaller than 2, plug into here, into f double prime, you'll get a negative. Plug any number bigger than 2 into the second derivative, you'll get a positive. This shows that f starts out concave down and then is concave up. So inflection point is where x is 2. To find what y is, you got to plug 2 into here. 2 times 2 cubed minus 12 times 2 squared plus 30. And when you do that, you'll get negative 2. So 2, negative 2 is called the inflection point. And we already see that that's where the graph changes from concave down to concave up. That's just reading this. The vertical the vertical intercept is also called the y-intercept, and that's just when x is 0. Y-intercept is when x is 0. We already determined earlier that when x is 0, y is 30. The point 0, 30, that's where the graph is on the y-axis, or the vertical intercept. For elasticity, we need the derivative of q with respect to p, which is 0 minus 4 minus 2p. We also need we need q when p is 10. Q when p is 10 is 500 minus 4 times 10 minus 10 squared, which is 360. We also need the derivative of q with respect to p when p is 10. And that would be from this, negative 4 minus 2 times 10. That's negative 24. To find the elasticity of demand, we use this formula from your notes. P over Q times the derivative of Q with respect to P. And elasticity will always be positive. Absolute value of P over Q times the derivative of Q with respect to P. Elasticity of demand is P over Q times the derivative of Q with respect to P inside absolute value. P is given, it's 10. Q is what we found. When P is 10, Q is 360. And the derivative of Q with respect to P when P is 10 is negative 24. All of this is inside absolute value. 10 times negative 24 is negative 240. That's over 360 times 1. But that's absolute value, so that just means positive 240 over 360, which can be reduced to 2/3. Then also in your notes, you have this. If elasticity is less than 1, demand is inelastic. 2/3 is less than 1. If the elasticity came out greater than 1, we would have said elastic. When elasticity is less than 1, raising prices increases revenue. Raising prices increases revenue.